Academia at the moment is a really fantastic place to be in terms of working within deep learning and machine learning. If we look at some of the work that's been done in the universities like UCL and KCL around neurology, around trying to do predictive analysis into stroke treatments and other treatments as well, it's really fantastic work, and this is going to be a big positive to all of the users of the health system within the United Kingdom. It will change lives for people, it will give them better services. The energy within machine learning and deep learning within the academic area is really bubbling over. It's a great place to be working. So one of the primary problems that we face when dealing with the universities is effectively a patchwork of infrastructure. So unfortunately, with a lot of the university, they will have a centralized IT department. But with the new technologies like machine learning and deep learning, what we're finding more and more is these platforms are siloed away from the main system admin central IT infrastructure. And with these silos, what will happen is you'll have a silo here and the main compute infrastructure here. And because they're not communicating via the system admins in the centralized IT, these individual silos, which are being managed by individual research teams, they do come into a lot of situations where they're not able to optimize the software, or they're not able to optimize the hardware, because they don't have access sometimes to that centralized compute resource. So again, if we can take the silos and build them into a more incorporated data hub, the benefits for the universities are huge. Now, one of the primary reasons why the infrastructure really matters in relation to machine learning and deep learning is because the amount of investment that's required by these universities to have the correct resources for the research groups to grow. And in the case of machine learning and deep learning, that does pose some challenges for universities. And the reason is the amount of cost associated to the machine learning and deep learning infrastructure that you need to acquire is huge. Typically far more expensive than the computer science teams have been exposed to previously. So if your levels of investment are so much higher than the typical computer science spend would be, then as a result, the universities are really looking to have some very strong comfort blankets in place when they're procuring this hardware. One of the other reasons why infrastructure really matters is because if in the event that a university acquires the wrong technology, then the repercussions can be very, very serious. You can imagine a scenario if you're in charge of procurement for a project and your outlay is, let's just say it's £1 million, and when the infrastructure is online, the feedback from the research groups is the performance increase that they were expecting to see hasn't materialized, or the software stacks on the hardware aren't able to manage the workloads that they've got, then that's going to cause some very, very serious problems. So it's very important to work with the correct partner, understand the data that you're currently managing and the correct platforms to manage that data, and to most importantly, not make a quick decision. Really speak to your partners, speak to the OEMs, understand what's required, and then move forward with a project. When we're looking at infrastructure, as I said to you, the infrastructure is very much dependent on the jobs that are going to be managed on that infrastructure, the data that effectively is being managed. And there are some platforms out there that are very generic. It's basically a box of GPUs which is designed to try and manage any workload capabilities. But there's also some specialized boxes out there as well which are intended to be used within specific areas of research. So if we were to look at the AC922 deep learning box from IBM, this is a IBM server with 4 V100 GPUs from NVIDIA, and this system is unique in the fact that it's currently the only system currently available worldwide which incorporates NVIDIA's NVLink technology not only on the GPUs but also on the CPU. Effectively what this means is your bandwidth is extended massively and you can run those jobs far quicker on the AC922 deep learning nodes. The AC922 comes with some very specific and unique software called large model support. And with large model support, IBM have a unique strategy whereby they are utilizing system cache memory and bypassing the GPU memory buffers. What this means in terms of training models on an AC922 with medical imagery is you're able to process those images within the training sets far quicker than if you were having a system that was utilizing the GPU buffers. Now, in any area of research, if you're able to decrease your hardware need by 50%, then that's going to have a profound impact on the business model for that organization. And this is one of the key things that the IBM 18922 is able to achieve. We also have to think about storage, because if we're talking about a fully optimized ecosystem, then we have to incorporate all of the parts that make up that ecosystem. And one of the parts which is usually forgotten about when looking at the infrastructure projects is the storage. So in the case of deep learning specifically, we would be typically looking at a flash-based storage platform. And that's because the investment levels in these platforms are so high, we want a transfer of all of this data to be as humanly possible fast as it can be. Again, if you're working on a patchwork system and you've got manufacturer A, B, and C, you're naturally gonna run into problems because of the different architecture and the software on these platforms. One of the things, if you're an AI startup or a deep tech startup, one of the most important things is to bring your company's product or service to market as quick as you can. Because the chances that another startup are working on a similar application platform are probably going to be relatively high. So if you're able to bring your product to market before your competition are, you're going to be in a far better place. We see a dramatic increase, or I should say a dramatic decrease in the amount of time it takes for a typical startup to go from inception to a full deployment model. So we work very closely with some of the universities in the United Kingdom to help power their incubators. And of course, we would be open to working with more universities in the United Kingdom.